Hello everyone, welcome back to lecture series on data structure. In this session we will be creating a single linked list by adding the node at a start. Now the editor which I am using over here is the CodeLight editor. You can use any of the editor. So now to start with it, what I will do, I will first add one file and I name that file as singly linked list. Okay, I keep the same extension .cpp. As we are creating the file in C++, I will include the header file iostream followed by using namespace std. Okay, now we will be creating the linked list using a structure. Now to create a structure in C++, we use the keyword struct followed by the name of the node. So I keep the name of the node itself as node, and in this node we'll be having two parts. In first part we'll be storing the data, and the second part will be storing or we'll be having the pointer of type node only, or the structure node. Now the data what we'll be storing will be, let us say we are going to store only integer values. So I declare one variable int x, and the pointer that will pointing to the next nodes. Okay, that pointer has to be of the same type as the struct node, and let's say I'm naming that pointer as a next pointer. Now apart from this, the very first node of the list will be set as head. So what we'll do, we'll create one head node because this is starting point from where the linked list will start, and again it's going to be a pointer, so we name it as head node, and we create it as struct node asterisk head indicating that it's a pointer, and initially it will be null. We are creating this list by adding the node at first. Okay, so let us say we create one method called add at first, and we call upon this method from main method add at first. So whenever we call upon this method, the first thing that will be prompted is enter the number, and that number will store it in value integer x, or the variable x. So for that purpose we'll first create one dummy node of type struct node. Okay, so struct node, and it's a dummy pointer, so let it be temp. But after creating that, we need to allocate the space. As we are it's a pointer, we have to specify that it's of struct node, and the memory allocation will be done by using the keyword malloc, and the size required is of this node, so size of struct node asterisk. So this is basically how the size is allocated. Now after this, let us say the very first statement that will prompted is enter the number. Now this number will be storing in variable x. Okay, so to store into that, we can simply write cin temp, and to access the data member of the structure we use arrow hyphen. Okay, so cin temp x, and next the next pointer of this temp node, it must be empty, so we just write temp next equal to null. And we are creating the list by adding the element at first. Now the element will be added to the first subject to condition the list exists. List exists in the sense the head pointer should be there. Right now we are set head equal to null. That means while we start execute this application, initially head will be null. So whatever the node we are adding, that node will be the first node. So for that purpose, we'll write over here if head equal to null, then whatever the node we have added or we have created, okay, that node will be the head node. So right now the node what we have created is temp node, so in that case we say head equal to temp. However, if the list exists, that means there are few elements in the list. Let us say, as discussed in the previous session, let us say we are having the list as 10, 20, 30 and 40. After 40 there are no elements, so next pointer of 40 is null. So now in this case head is at 10, and let us say the new element or the new node which we have created is temp. In that we are storing value 50. So at the end we require the output to be something like this: 50 to 10, 10 to 20, 20 to 30, and 30 to 40. That means 50 should be the first element. In that case, what we should do is, right now the next pointer of temp is pointing at null. So instead of making it null, what we should do is, we should say the next pointer of temp is pointing to head. Okay, so if we want to say next pointer of temp is pointing to head, then we do like this: temp next, it's equal to head. So with this case, what will happen, we'll get the list something like this: 50 to 10, 10 to 20, 20 to 30, 30 to 40, but the head pointer is still pointing at 10. So we need to shift the head, which is pointing at 10. Instead of 10, it should point to 50, and 50 is identified by node temp. So here we'll simply say head equal to 10. So after this, we'll say head equal to 10. That's it. So this is how we add the element at first. Okay, but now after adding, let us say we want to display the list. Okay, so for display purpose, we use another function, void disp. Okay, again we'll create one temporary pointer. Okay, because we are not sure whether list exists or not, so let us create one temporary pointer of type node. Okay, again it has to be the pointer, so we write asterisk temp. Now initially, before we display the list, we are not sure whether list exists or not. For that purpose, we'll check upon if head equal to null. If head is null, that means list is empty. So cout \n, nothing to display, list is empty. Okay, I write over here \n, list is empty. Okay, this will come only in the case if head is null. Okay, I should keep this in one block. So let me cut this and paste inside the block. Okay, now what if the list exists? Okay, in the case the list exists, then we'll say temp equal to head. We won't move head per pointer to anywhere. Instead of that, we'll be using another pointer temp, and using that temp we'll move to the end of the list, and end of the list is identified when the next pointer is null. That means while next pointer of temp is not equal to null. If it's not equal to null, then what you do, you display the current value of that particular node. So cout, you display the value x and keep we can't write x. Wait a minute, something happened. Just a second. Okay, we cannot directly access the value temp. Okay, not temp, we cannot directly access the data member of a structure, so for that we need to use the structure itself. So temp x, okay, and keep some space, and thereafter you move to the next node. And to move to the next node, we simply from the current node is temp. To move to the next node, we'll simply write temp equal to temp next. That's it. Okay, so this is how we will be moving to the end of the list. Let me show you over here that thing we have done with this in the last session. Okay, something like this. Initially we are at head. Okay, so we have the list as 10 to 20, 20 to 30, 30 to 40. Okay, so what we have done, we have created one temporary node called temp, and temp is pointing at temp equal to head. That means both temp and head are pointing to the node where we have stored the value 10. What we are doing over here is we are checking whether the next pointer is null. So if the next pointer is null, that means we have reached end of the list. Okay, so we are saying while temp next is not equal to null, we'll display the value of x, and we are moving ahead by simply saying temp equal to temp next. So let us say with this, what will happen, initially temp is at 10, so whether the next pointer of 10 is null, no. So we'll display the value of x and we move ahead by simply saying temp equal to temp next. Temp next points to 20. So now temp is at 20. Now again at 20 we'll check whether the next pointer is null. No, next pointer of 20 is not null. So we'll display the value of 20 and we move ahead. Now temp is at 30. So at 30 we'll check whether the next pointer is of 30 is null. No, it's not null. So we'll display the value of 30 and we move ahead. Now the temp is at 40. So whether the next pointer of temp equal to null? Yes. So this loop breaks out. So we haven't displayed the value of 40. So after the loop we'll display the value of temp, that is the last node. Okay, so after this we'll write cout temp x. Okay, so this is how we'll display the complete list. And to implement this list or to check up on this list, what we'll do in main method, anyways, it has to be while we implement this, it will be in the form of something called choice based or menu driven, wherein we'll provide the option to the users whether to add or to remove or something like this. So right now what we'll do is we'll just take like this. We'll call upon this add method 5 times and then we'll display the list. So it goes like this: for I equal to 1, I less than equal to 5, I plus plus. I'll call upon the simple method add at first. Let me check upon the how I return the function name add at first. Yeah, it's proper. Okay, and after this I'll call upon the method this. That's it. And let me have one statement \n. Again, when it happens that we are dealing with the linked list with all the functions, right now the function which we are implementing is only adding the list or adding the node at first. So if it happens that we are dealing with the full-fledged linked list application, then at that time we must know how many nodes are there in the list. For that purpose, what we can do is within this only we'll make one change. We'll declare one global variable and we declare that global variable c equal to 0. And whenever we are adding the node, so here we are saying add at first. Okay, so whenever we are adding the node, what we'll do, we'll just increment that value by 1. That we will simply say c plus plus. So whether we are adding the element at the first, that means whether it's a head element or the another element. So every time this loops gets executed or this function gets executed, a new node is getting added. So what will happen, the value of c, which is basically a counter, it will get incremented. Okay, so now let's compile this and check upon if there are any errors. So let me compile this. Where is the error box? Okay, here it is. So is it displaying any error? Okay, the font size is too big, so let me reduce the font size. So it's 41, so let it be 20. Okay, so it's saying with one error, void display. I think it's something else. So it was checking for some other file. So let me compile this. Okay, so it built successfully. So there are some other files also in the list. So let me remove this. So right now we are having only one file over here. Okay, so this file is without any error. So and if we execute this, so it's getting worked in the terminal over here. Now over here enter the number. So number is 10. Right now we don't have any list number in the list, or the list is empty. So 10 will become my first element. Okay, then again it's asking because we have used the loop over here. Along this we have used loop. So now 20. Now 20 we are adding at first. So list will become 20 and then 10, and it's not 10 and 20. We are adding 20 at first. So the moment we enter 20 over here, then now list becomes 20 to 10. Then we are adding again 30 So list will become 30 to 20, 20 to 10. After 10 it will be null. Similarly 40 and 50. So this loop got or this function was called 5 times by using the for loop, and after that we are calling the this method. Okay, so basically it should have been 10 to 20, 20 to 30, 30 to 40 and 40 to 50, but this is not the way, because we are adding the node at start. So the first 10, okay, then we are adding 20, we are adding 20 at first, so the list will be 20 to 10. Okay, and now if we execute this, here we get 50 to 40, 40 to 30, 30 to 20, 20 to 10. So that's it for this session. In the next session we will look into how to add the node at last. Thank you.